Hello, I'm Tom English, and this lesson I want to talk a little bit about estimating, and even more so than estimating is double checking your answers before you turn that paper in. One of the things that's so frustrating to see students do all the work, come up with an answer that is so outlandish, they should have known it didn't make sense, but they don't bother to go back over and check their answers for reasonableness. Let me show you an example. Let's say we want to multiply 11.5 times 32.6, and classically what happens is a student puts it into the calculator, comes up with this answer and says, it's got to be right, it came from the calculator. And I agree that calculators generally don't make mistakes, but I find that students sometimes do. And one of the biggest mistakes is, oh, they forgot to put the decimal points in. And I say that there ought to be some estimating going on when they do this, to the point where they should know when the answer comes up whether it's reasonable or not. In this case, if you round these out, let's take 11.5 and let's just make it easy and say that's about 10. 32.6, that's about 30. We know they're light and so forth, but our answer should be somewhere around 300. And when you do that kind of analysis and you look at your answer, 37,000, you should right away say, oh, something's wrong. Let me do that again. And at that time, hopefully you discover, oh, I forgot to put the decimal points in and correct it. But if you don't go to that extra step and think through that, you're going to miss some problems that you shouldn't. Let's take another example. Let's say from geometry we know that the sum of the angles of a triangle, the sum of the angles is always going to be 180 degrees. Okay? That's a tried and true rule, and therefore if you come up with angles, let's say angle A was 40 degrees and angle B was 70 degrees and angle C was 110 degrees, and they put that down and okay, they go on to the next problem. And I said, well, wait a minute, did you even total those to see if they equal 180? Well, no. Why should I? Well, the problem is that you're taking a fairly simple problem maybe and you're going to miss it because you didn't double check. In this case, I challenge them, add 40, 70, 110. In this case, we get 220 degrees. Say, well, wait a minute, it's supposed to be 180. I did something wrong. Go back over the problem. Another example might be an algebra problem. Let's just say we had 3x plus 2 is equal to 2x minus 5. And so you go through the problem and you say, let's see, I want to get all the x's on one side, everything else on the other side. So I'm going to subtract 2x from this side, then I'll subtract 2x from this side, and I end up with x plus 2 is equal to negative 5. Well, I got to take the 2 over to the other side, so now I end up with an answer of x is equal to negative 7. Don't stop there. Take that answer and put it back into the original equation. Always into the original one, not one of the ones that came, because you might have made the first error in shortening that. So we put negative 7 in for x, and we have 3 times the negative 7 plus 2. Is that equal to 2 times the negative 7 minus 5? Well, 3 times 7, that's negative 21, plus 2, that's a negative 19. 2 times the negative 7 is negative 14, and a negative 5, that is also a minus 19. Guess what? Our answer is correct. So, encourage your children, do the extra step, go the extra step, do some estimating so you have an idea of what the answer should be. And in the case of some of these where you know exactly what the total should be, go through the effort to total it. You're going to find that your grades are going to improve when you take those extra steps. Thank you.